Hi, everybody, and welcome back to the Dark Reading News Desk. I'm Becky Bracken, editor with Dark Reading, and now I would like to welcome Chris Wysopal, CTO and founder of Veracode, who is here to talk about his briefing from How to Halt, Thwarting Skynet's Siblings in the GenAI Coding Era. Thanks so much for joining us, Chris.
Thanks for having me.
Okay, so walk us through, we were talking a little bit before this about how you came up with the title for your briefing. Can you tell us a little bit about that?
Yeah, so I actually used ChatGPT to come up with the title. I said, let's come up with something funny. I'm going to be talking about how AI code generation can create vulnerabilities in code, and that's a problem. What's a lighthearted way to talk about this serious topic? And it came up with, from How to Halt, Thwarting Skynet's Siblings in the GenAI Coding Era.
Okay, and Hal referencing our 2001 Space Odyssey.
Yes,
friend.
so Hal was an AI which kind of went rogue at the end and killed the astronauts.
Excellent. So you are looking at really the feasibility of using GenAI to create secure code today, correct?
Absolutely, yes.
And what are you finding?
So there's no doubt that GenAI code generation is a big productivity boost.
Sure.
There's data out there saying it's 30 to 50% productivity boost. Wow. Over a developer that's not using this. So what company doesn't want their software team to have 30 to 50% more resources or developers? Mm-hmm. So it's going to be used. It's popular. The thing is, you have to understand what are the downsides of using GenAI code tools. And I'm trying to raise awareness that, while it might make good functional code that does what you want it to do, it's also generating vulnerabilities, much like human developers do. It shouldn't be really surprising that when it learned based on open source code and other coding sources, it learned how to code like a regular developer would.
And we can see this now in open source repositories, your log4js and your vulnerabilities that creep in there.
Absolutely.
This could kind of be exponentially worse, right?
So the difference with this is from the code that's made by regular developers is it can write a lot more code a lot faster. So what you end up doing is creating more code and more vulnerabilities per unit of time. Right? We're trying to accelerate everything in software development. Mm-hmm. And if you actually accelerate the code generation process and the code generation process is creating vulnerabilities at the same kind of density that a human coder would, what you're doing is you're accelerating the number of vulnerabilities you need to deal with. So you need to figure out, how do I find vulnerabilities faster? And most importantly, how do I fix vulnerabilities faster? Because I have to fix these problems or I end up with vulnerable software.
So let's kind of go around the AI landscape and which of the models that exist right now are good at writing code?
Yeah, so there's a new framework that came out, I think it just came out a month ago from Notre Dame, where they came up with a way to test LLMs and look at the code they generate and see which one creates more vulnerabilities. They're doing it on Python code. They create 100 Python applications, and then they analyze them. And it turns out that there's this coding-specific LLM called StarCoder, which actually makes the least vulnerable code.
But not no
vulnerabilities.
Code, right.
No vulnerabilities. And then behind it was ChatGPT 4.0, and then ChatGPT 3.5, and then there were some other LLMs they looked at. I can't remember the name of them all that were worse. And so I think this is a great framework because it just raises awareness that choosing the LLM you use actually can make a difference with how secure the code's going to be.
And it sounds very similar to what we do with just language in AI. I mean, it'll spit out something, but that editing process, separating the wheat from the chaff, can be almost more cumbersome than just starting from scratch. Is that sort of the same comparison?
It's sort of the same thing. You wanna. It's sort of like why you would train your developers to write secure code.
Right.
They're not going to be perfect. They're still going to write code that has vulnerabilities, but you want a better starting point.
It does sound like this. That the lure of the productivity boost and the hard push that the entire sector is trying to make on this shift left idea,
yes,
developing secure code, and it's almost like they're diametrically opposed, that they're sort of pushing against one another. How will that sort out?
So the people like me who have been in application security for a while, we've had to change our processes to keep up with the tooling that developers are using, right? So it used to be developers would write code for a month, then we'd run tests for a few days, we'd fix the issues, and we'd push it to production. Right. Then DevOps came along, and you write a little code, you test a little code, you push a little code to production. So we had to figure out, well, how do we run a security test on that little piece of code as fast as the developers are moving, pushing multiple times a day? So then we came up with DevSecOps and built the tools into the development pipeline, made it part of the process. Now with AI code generation, I feel like we're getting even faster, and now we need something to deal with the fact that vulnerabilities are going to be found at a faster rate. We don't want to slow down the development process with humans fixing the code. So one of the things I'm proposing is if you're going to generate code with AI, you're going to need to fix the code with AI.
And how good is it at that?
So a general purpose LLM can fix some security bugs, but it turns out it's not great at it. And so we're seeing specialized LLMs that are trained just to secure code. This is one of the things we're doing at Veracode. Mm-hmm. There's other companies doing this. We've trained an LLM on how to write secure code. If you see a coding pattern that's insecure, like cross-site scripting, SQL injection, this is how you want to change it to a secure coding pattern. And so we can then automatically fix these vulnerabilities, just like you're writing code with GenAI, we're going to fix vulnerabilities with GenAI. And I think that's kind of the future of how to keep up.
And so one can assume that the code that you're using in your models is pristine and clean, and it's being trained on clean code.
Right, so it's all about the training data set. And if you're going to train on all of the open source code, you're going to get code that kind of looks like open source code. And we know there's new open source vulnerabilities being found on a daily basis.
Right.
Some of them massively bad, like Log4j, where they're widespread. But even something which is in a package that maybe has 100 deployments or 100 users, it's going to learn on these projects that might not have the same level of security scrutiny that developers at the Apache project did for Log4j. Right. So that's one of the problems. It's learning from all these small projects. It's learning from code that students have written, right? Students use GitHub, and that's publicly available. So it's learned a lot of these bad practices. What you want a data set that's curated to be known to be secure code.
Sure.
So known bad code, known secure code, and you also want to do supervised learning. One of the supervised learning is expensive because basically you need an expert to then check to make sure the right answer.
What is supervised learning? I'm not.
So with supervised learning, what you do is you say, okay, I want my LLM to fix SQL injection in Java.
Okay.
So I'm going to come up with a bunch of examples of SQL injection, bad SQL queries, bad code. Then I'm going to come up with a set of good ones. And I'm going to train the LLM. If you see something that looks like this bad pattern, you want to be able to generate the good pattern. Then what you're going to do is you're going to actually use the LLM with a human expert and see if it actually has the right answer. And if it doesn't have the right answer, you trained it poorly. There's really no such thing as the supervised learning on these foundational LLMs because you would need an expert in every topic in the world.
It would be too expensive and cumbersome.
It would be way too expensive. So those are just unsupervised learning, and we just hope it doesn't hallucinate, right? We just hope it's learned more of the correct answers than the wrong answers, and that most of the time it will be correct. Hopefully it's correct almost all the time.
Right.
But with supervised learning, you can make sure it's correct.
That is a fascinating topic. Can you tell our audience where they can learn more about this?
Yes. So you can learn more about what we've done at Veracode at the Veracode website. We have a page on Veracode Fix, and we have a blog post. We talk about how we've gone through the process of making our LLM be smart here.
Wonderful. Thank you so much for your important work and for sharing it with us today at the Dark Reading News Desk.
Absolutely. Thank you for having me.
Thank you. That was Chris Wysopal, CTO of Veracode.